Hey guys, this is Nurluda and I am a verified educator at an academy. Along with that, I am teaching live on an Academy Plus. It's a live platform where educators like me are taking live classes for various competitive exams. I personally teach for CSIR Net, GATE, and TIFR exam. So if you guys are preparing for upcoming CSIR Net, GATE, or TIFR exam, you can subscribe to my classes and you can join my classes on Unacademy Plus. So for that, what you have to do is take Unacademy Plus subscription and there you can attend my classes live over there. Now for that, if you put my referral code, that is n underscore huda, while taking subscription, you will get a discount of 10% on your subscription fee. There are also many offline lessons available on Unacademy. You can enhance your problem solving skills by watching those offline videos as well. So that's all from for this particular part. Now let's continue with our video.
Hey guys, hello everyone and welcome to the channel. So in this particular video I'm going to solve questions which were asked from thermodynamics portion of your CSIR NET June 2019 exam. Now you all are aware of it that physical chemistry was not that much easy, especially in this CSIR NET exam, and that's why the cutoff was low, and I was getting a lot of requests from you guys to solve questions related to it, and I thought that you should know the answer, like how to solve these questions, because many of them were tricky. There were some formula which were very different, which were not asked usually in CSI NET exam. So it's just an effort of mine. I have just compiled all 3-4 questions which were asked from part C of your thermodynamics. I have already solved part B of physical chemistry. You can find out the link of that over here in the I button. Okay, so you can click over here and you can like watch that video if you have not watched yet. But yeah, in this video I'll be solving all the questions from thermodynamics portion, like 3-4 questions were there. And yeah, so enjoy this particular video, watch this carefully, learn new things, learn the new formula and the way how the question has to be solved. And yes, one more thing, that do let me know in the comment section that like if you guys want more videos like this, you want more solutions of previous years, like especially of this June 2019 exam, like the other physical chemistry question solutions, or you guys want to like you want me to teach other topics. Okay, so do let me know in the comment section, and yeah, watch this video carefully. And one more thing, if you're new to this channel, do subscribe it and do give it a like if you like this particular video. So from the next part you will be having clips of the solutions. Alright, so we'll talk about this question over here. It was asked for 4 marks again, and the question was actually from your statistical thermodynamics. A lot of things was taken from there. And yeah, so it says like basically it's a combination of your thermodynamics and statistical thermodynamics. We'll try to solve this up, right? So it says that the difference between the standard molar entropies of the two monoatomic gases A and B, that is S naught Ma and S naught Mb, where M denotes that it's a monoatomic gas, A and B specifies that you're talking about gas A and gas B respectively. Now at a given temperature will be, okay, so that's what they are asking, and it's given that the molar mass of A is twice that of molar mass of B. That means Ma is equals to twice of Mb. That's what is already given to you, right? So we'll try to solve this up. So what you have to use, you should know a particular equation basically, right? So to solve this up, you need to know a equation to calculate molar entropy. So S naught M of a monatomic gas is given by this formula, that is R ln Q plus RT del ln Q by del T at constant V. Okay, so where this Q is your partition function, and Q, the value of Q for a monatomic gas is actually given by this, that is Q is equals to 2 pi m kt by h square and whole to the power 3 by 2. So that's what your q comes out, right? So now we will do one thing, that we will take ln q, because we need ln q in this equation. So we'll take ln q, and that will be equal to 3 by 2 ln 2 pi mkt by h square, right? Because that power will come outside, so it will be like that. And then again you have to take, or you can take that t outside of it. So basically your ln q will become 3 by 2 ln 2 pi mk by h square, and plus you will be having 3 by 2 ln t. So this is what you will get. Okay, so just make it equation number 1. Just remember this. Okay, so I'm just making it inside this box just to make sure that I remember this equation. Now I have to take the next part of it, that is I also need this part, that is del ln q by del t. So I have to solve that as well. So I'm going to take the ln part of this with like I have to differentiate this with respect to t. So that's what I'm going to do. So del ln q by del t at constant v, that's what I'm going to calculate now. See, this particular whole part is actually constant. Why? Because your 2 pi is a constant, mass also remains, that is not a function of temperature basically. K is also not a function of temperature. K is a Boltzmann constant, H is your Planck constant, so everything is a constant. If you differentiate that with respect to t, you will get 0. So this particular whole term will become 0. The only term which will be left out is 3 by 2 ln t. Now ln t, the differentiation law of ln t becomes 1 by t. So what will be the answer? So 3 by 2 into 1 by t. So that's what you will get. So make sure you remember this also. So this is your equation number 2. Now I have to just put these values in this particular equation to calculate S naught, right? So I have two different gases. So I'll do for both of them. Okay, just a sec. Let me just erase these things. Okay, fine. So what I will get is this, that is S naught MA, that is for A, it will be like 3 by 2. Okay, I'm just putting everything over here. I'm putting ln q over here and I'm putting del ln q by del t at constant v over here. So I'll just, when I'll put, it will become 3 by 2 r ln, okay, that means ln 2 pi ma. Now it will be ma because I'm specifying it as mass of atom A, kt by h square. Okay, right, now plus I'll be having RT into 3 by 2 T, right? So that's what I'll get for A. Similarly for S naught MB, I'll be having this, that is 3 by 2 R ln 2 pi MB KT divided by H square, okay, plus RT into 3 by 2T. So this t and this t will be cancelled out. Here also these two will be cancelled out. What they're asking is the subtraction or the difference of these two. So just take difference of both of these values. So S naught MA minus S naught MB, that's what you have to calculate. When you subtract, so basically these terms are same, so they will be solved and they will be cancelled out. And if you take out the rest of the term, or if you express it in this form, that is if you can express S naught MA like this, it will be 3 by 2 R ln 2 pi, okay, so you can express it like this, that is 2 pi, okay, now don't put m, 2 pi kt by h square, this will be one of the bracket, and plus you can put it like this, 3 by 2 r, okay, ln ma. So basically what I'm doing, I'm just separating out ma. In the same way I can write down this, that is S naught mb is equals to 3 by 2 r ln 2 pi kt by h square plus 3 by 2 r ln mb, right? What I'm doing, I'm just taking out this ma and this mb out of it because we just need that thing. Rest of the thing are constant. See, this is also constant, this is also constant. So basically when you will subtract this, they will also get cancelled out. So what will be left out, that only I'll just write down here. Okay, so what will be left out, that will be just 3 by 2 r ln ma minus 3 by 2 r ln mb. Okay, so that is the only thing which will be left out. Now you know what you have to do next, right? What you have to do next, you have to just solve it up. So I'll do it in the space provided. So I'll just do over here in this particular space rest of the things. So what it will be, so S naught ma minus S naught mb, and that will be equal to 3 by 2 3 by 2 r ln ma by mb. Now you know ma by mb is given, like ma is equals to twice of mb. So when you substitute that, mb will be cancelled out and you will get 2 over here, ln 2, right? So the answer will be 3 by 2 r ln 2. So basically your answer is your option number 1. So that is how you have to do. I know there was less space on the screen, but I tried to manage it up. If you are making out notes or if you are solving it somewhere in your notes, do write it out properly, right? So this is how it will be done. First of all, you need to know the formula for entropy of monatomic gas. Then you need to know the formula of like partition function, and then you have to substitute everything, put as per the given condition, and then you are done with it, right? Let's take the next question then. All right, so we'll take the next question. And over here it is said that a non-ideal gas follows the equation. This is the equation given, right? P is equals to RT by Vm, and in the bracket you have 1 plus B by Vm, where B is a function of temperature only. That's what it is given. And it is asked that the deviation in the internal energy from that of ideal gas, that is U minus U ideal, is given by. So that's what they are asking, right? So we'll try to do this particular thing. Now before going into this particular question, you should know something, right? So first thing is that the equation which you should know is first thermodynamics thermodynamic equation of state. So this equation you should know, right? And this is the equation which is being used to solve this whole question. So that is given by del u by del v at constant t, and that is equals to t del p by del t at constant v minus p. So this equation is called first thermodynamic equation of state. All right, so we'll do now rest of the things. The thing which is given to you, that is p is given to you, that is equal to actually RT by Vm, and in the bracket I have 1 plus B by Vm. So I'll just multiply this, and this will actually become equal to like I can write it as or I can erase this or, and I can write it equal to actually RT by Vm, okay, and then plus BRT by Vm square. So that is how I can write down this P as, okay. But in this thermodynamic equation state, you can see that I need del P by del T, all right, at constant V. So now I'm going to calculate that. So I'm going to calculate del P by del T at constant V from this equation, okay, from this particular equation. So what I'll get when I'll differentiate this, so when I will differentiate this part, since I'm differentiating with respect to t and v is constant, so only t will be differentiated, and the differentiation of t will be actually 1. So we'll just get r by vm, all right. And yeah, so we'll get r by vm, and along with that we will use the second part. And since b is the function of temperature, so we have to use the product rule. In that, we'll first use, like, we'll write down plus, and we will take b outside that, so b r by v square, and the differentiation of t will be 1, so it will be like b r by v square, and plus, now we'll take t outside, so it will be like r t by vm square, and we'll differentiate b, so that will be equal to like del b by del, okay, so it will be del b by del t, oh sorry, yeah, del b by del t at constant v. That's what I'll get. Okay, so what I have done, I have just differentiated this. This part can be easily differentiated. This particular part requires a product rule because b and t both are functions of t. So I have just used the product rule of differentiation. Those who don't know about product rule, I have explained all of these in my Unacademy video. So if you are following me over there, I have like given all these things how to solve them. So you can follow that video and do these kind of questions from there, right? So next thing is, yeah, so the next thing, I'm going to put the values of this particular thing and the value of p in the equation of del u by del v at constant t. Okay, so I'll just use my next color of pen. So what I'm going to get is del u by del v at constant t is equals to t into del p. So that means this whole term will have to be multiplied by t. So I'll get rt by vm plus vtr by, this would be Vm. So Vm square plus RT square by Vm square and del B by del T. Okay, so this is what you will get minus P, the value of P. The value of P, I'll take it from here. So it will be RT by Vm, okay, and minus BRT by Vm square. Now you can see that two of the terms will be cancelled out from here. right? It's pretty simple. You can easily see that this particular part and this particular part are simple. They are in opposite signs, so they will be cancelled out, and this part and this part are in opposite signs, so they will be cancelled out. So what will be left out, that will be, I'll be just writing down over here. So del u by del v at constant t, that will be equal to actually rt square by vm square del b by del t at constant v. So that's what I'll get. Now the next thing is I have to, yeah, so the next thing is I have to just like take out this del v to the other side and integrate these equations. So I'll be having del u is equals to rt by, or rt, like denominator I'm not going to write down, so it will be del b by del t at constant v into 1 by vm square dv. Okay, what I have done, I have taken this dv to the other side from this equation, and now I'll just integrate these equations. Okay, so integration of del u will give you u, and that will be equal to, okay, so this part I'll just write down. So integration of v square, like 1 by v square, that will be equal to minus 1 upon v. Okay, vm or v, both are the same things. Vm is just specifying that you are talking about a particular gas which is given in the equation. So since it was given as vm, so that's why we are writing it as, but it's actually volume only. So we can express, like we can just integrate this particular part. So what you will get, so rt del b by del t at constant v will be same, and the integration part of this you will get as minus 1 by vm. Okay, so that's what you will get. So this is what you will get as the value of u, or I can write it down in this way, that is, I'll just write it down over here. Okay, and then I'll use the next slide. So u is equals to what, that will be equal to, u will be equal to actually minus rt square, because the square we had just missed. Okay, here was a square, right? So we have to write down square also. So yeah, rt square by vm and del b by del t at constant v. Now you can figure it out, what will be the answer. How? Because you know that u ideal, for ideal gas, internal energy is actually equal to 0. So if you want to calculate u minus u ideal, so if u ideal is 0, so basically u minus u ideal will be same as the value of u. That means this, that is minus rt square by vm del b by del t at constant v. So what should be the answer? The answer should be your option number 2. So that's how you have to do this question. It was very tricky, and like you need to know the formula, you need to know how to put, how to integrate, where to differentiate, and everything, right? So I hope this helped you, and this just open up some of your mind. You just got to know that, okay, what you have to do in exam, and up to what level you have to be prepared for the exam, right? All right, so let's take some more questions now. Alright, so this particular question is pretty simple and more straightforward as compared to the previous ones. Okay, and this is, I think, the easiest question which was asked from thermodynamics this time in June 2019. Okay, so the question says that when 2 moles of liquid A are mixed up with 2 moles of liquid B at 300 Kelvin, the excess molar Gibbs energy of the solution is, okay, that is given that minus 1.5 kilojoule per mole. Okay, so the corresponding value of Gibbs energy of mixing in kilojoule is closest to, and you have given with the R value. So you have to calculate that. Okay, so if you don't know, this is the formula which we will use. So delta G of mixing, that is actually equal to my like nRT. Okay, it's actually equal to nRT sigma. Okay, sigma xi ln xi. So this is the formula which we are going to use. X is the mole fraction. Now a mole fraction is number of moles divided by total number of moles. So both of the gases, like both of the liquids are 2 moles. So that xi will be equal to 2 upon 4, right? Because total moles will be 2 plus 2, 4. And total number of moles, n will be the total number of moles, so that will be 4 actually. So that will be 4 RT, and in the bracket I'll be writing it out as 2 by 4 ln 2 by 4 plus 2 by 4 ln 2 by 4. For both the gas, for both the liquid, the value of xi ln xi will be same because both of them are taken 2 moles, right? So I can calculate it. That's all what you have to do. Okay, so 4 RT, it's 4 RT. Okay, and into 2 into 2 by 4 ln 2 by 4, right? So these will cancel out this particular 4. So basically what you will get is 4 RT ln 1 by 2, or you do it other side, so it will be equal to 4 RT. Okay, so 4 RT ln, okay, so ln 1 minus ln 2. Okay, ln 1 is 0, so that will come out minus ln 2. So minus 4 RT ln 2, that's what you will get. Now just put the values and just calculate, that's all. So minus 4 into 8.3, that's given to you in the question. T is given 300 Kelvin, and you have to convert ln into natural log. For that we write it down like 2.303, and then log 2. Log 2 value everyone knows, right? So that is 0.3010. So when you will solve this whole, you will get it around 6811 something. Okay, so joules per mole, joules, that's what you will get the value of delta G. Or this will be in joules, so in kilojoule your delta G mixing will be equal to 6.811 kilojoule, right? And they are asking the closest value, so and with the negative sign, so the closest value is actually equal to minus 6.0. So this is how this question has to be done. This was the easiest one, right? Easiest solution, not much thing, like not many things to do. So I hope this was clear to you guys. Let's take some more questions. All right, so this I'm going to take as the last question of this video. Okay, and this is going to be quite lengthy. Okay, the calculation or the solution of this need a lot of phases during, like there will be a lot of phases during the solution. So like make your attention over here and try to understand what I'm doing, right? So the question says that you have to find out, for adiabatic reversible expansion, you have to find out the work done basically, or the internal energy. So since work done, sorry, your internal energy, sorry, your delta Q will be equal to 0, so your internal energy will be equal to the work done. So that's what you have to find out. Now that is one of the things which is very much clear. It's given that the sample of 2 moles of oxygen is assumed ideal at 500 Kelvin, expanded from 5 liter to 50 liters, right? So this is what it is given under adiabatic and reversible condition. The change in internal energy in kilojoules, that's what you have to calculate. The thing which is given to you is this, that is CV is given to you as 5 by 2 R. Okay, and next, your N value is given in the question, that is 2 moles. Your temperature T1, where initially it is, that is 500 Kelvin, right? And then your V1, that is the initial volume is 5 liter. Your final volume is actually 50 liter, right? So these are the things given to you. Also, if CV is given, you can calculate CP, right? So CP minus CV is equals to R. So by that you can calculate CP is equals to R plus CV. So if you put over here like the value of CV, so R plus 5 by 2 R, so this will give you 7 by 2 R, right? So this is the value of CP which you will get. So these are the things which are given to you, and that what we will be using during our solution. Okay, so let's try to solve this up. First of all, we'll calculate gamma, right? So gamma, you know that it is Cp upon Cv, and Cp upon Cv is equals to, that will be equal to 7 by 2R divided by 5 by 2R, so that will be equal to 7 by 5. So that will be the value of gamma, right? Now we know that work done under adiabatic reversible process is actually given by this formula, that is P2V2 minus P1V1 upon gamma minus 1. Okay, so this is the formula to calculate work done for adiabatic process, adiabatic reversible process. Now that's why I have calculated gamma, because we need it over here, right, in the equation. P1 V1 P2 V2, so we have to solve that as well. So first of all, we'll try to find out the value of P1 V1. Okay, so we can use that P1 V1, since it's an ideal gas given over there, it is given that you have to assume that as ideal. So P1 V1 is equals to nRT1. We will use this and our n is 2, r will be r, and temperature is given 500 Kelvin. So it will come out 1000 r. So that is the value of P1 V1, right? So this is how you calculated P1 V1. Now we need to find out P2 V2, and also we need to find out the rest of the things. So we'll do on the next slide then. Right, so we have calculated P1 V1 and that was equal to 1000 R. Right, now we have to calculate P2 V2. Now for adiabatic process we know this thing that your P1 V1 to the power gamma is equals to P2 V2 to the power gamma, right? Because PV to the power gamma is constant. So now what I'm going to do, I'm going to multiply with V1 over here and divide with V1. Similarly, I'm going to multiply with V2 and I'm going to divide with V2. That will not make any difference in the equation, right? But I can write it in this way, that is P1 V1 into V1 to the power gamma minus 1. This, the denominator V1 will go upside and it will give you gamma minus 1. Similarly, on the right hand side, we will be having P2 V2 and gamma to the P2 V2 and into V2 to the power gamma minus 1. Now what I'm going to do, I'm just going to find out P2 V2, that will be equal to P1 V1 into V1 by V2 whole to the power gamma minus 1. I have just kept it this side, taken this V2 to the other side in the bracket with gamma minus 1. So that is how it will be made, right? Everything is correct till now. So P2 V2 is equals to P1 V1, we have calculated, that was 1000 R, right? And we will put the value of V1. V1 was 5 liter, V2 was 50 liter, and to the power gamma, gamma was 7 by 5 minus 1. So this will actually give you 1000 R, and this will give you 1 by 10 and power 2 by 5, right? So that's what you will get. Now next I have to find out the work done. Okay, so work done was P2 V2 minus P1 V1, or I can write it like minus, I can take outside and I can write it as P1 V1 minus P2 V2 divided by gamma minus 1. Okay, so that's what I can do. So I'll put everything, the values of everything. So P1 V1 was actually equal to like 1000 R, okay, negative sign outside, minus 1000 R into 1 by 10 to the power 2 by 5. Okay, so that's what I will get in the numerator, and in the denominator I'll be having gamma is 7 by 5 minus 1. So basically I'll be having negative sign outside, then I can take 1000 R common from the numerator, and I'll be having 1 minus 1 by 10 to the power 2 by 5. Alright, divided by 2 by 5. Or I can write it in this way, that is uh, like minus 1000 R into 5 by 2. Alright, and in the bracket I'll be writing it as 1 minus 1 upon 100 to the power 1 by 5. What I have done, I just squared this 10 because it was power 2 by 5, so I can square the 10, it will become 100 to the power 1 by 5. So that is what I'll get. I'll solve it over here, so it will be around 500 times, right? Multiplying it, it will become how much? This will become minus 2500 R, and in the bracket I'll be having rest of the things. Now I'll do some of my calculations. Okay, so this is how you have to do with it. First thing is that you have to see that to the power 1 by 5, that means which value you multiply 5 times. Start with 2. So when you multiply 2 5 times, it becomes 32. And if you multiply 3 5 times, okay, so 81, 4 times 3 is 81, and it will be like 243. So you are not getting any value close to 100, right? So the value which will be close to 100 will be 2.5 to the power 5. Okay, and if you solve it up, you will get around 97.87 something. Okay, so this is what the value which you will get. So that means what, the approximate value of 10 to the like 100 to the power 1 by 5 can be written as, like 100 can be written as 2.5 to the power 5. So that's what you can do, right? So over here what you can do is you can write it like this: 1 minus 1 upon 2.5 to the power 5 whole to the power 1 by 5. Okay, it's just approximate value, otherwise you should be using calculator. Since the calculator is not allowed, so I'm just trying to do without calculator. Okay, I'll be just doing it over here on the screen. Next you will be getting minus 2500 r, and in the bracket you will be having the 5 and 1 by 5 will be cancelled out. You will be having 1 minus 1 upon 2.5. So 1 upon 2.5 will give you 0.4, and 1 minus 0.4 will give you how much? That will be giving you 0.6, right? So you will be having minus 2500 r into 0.6. Now put the value of r, it was given to you in the question, and it will be like minus 2500 into 8.3 into 0.6. And when you will solve this, that will come out to up to 3 decimal places. Reduce the decimal places and you will get value around minus 12.5 kilojoules. So that is going to be your answer. Why this is answer, although this is work done, but you know that your delta U is equals to delta Q plus W. So delta Q is 0 for adiabatic process, so your work done and internal energy is same. So whatever value of work done you are getting, that will be actually equal to your internal energy. So that is how your answer comes out to be your option number 2. Okay, so this is going to be your correct answer. So see, this was quite lengthy question, and I hope that you guys understood it well. Any doubt if you guys have, you can ask me in the comment section. And that's all for this particular video. Do tell me in the comment section if you guys liked it or not, and do tell me this, that if you guys want me to solve more questions from CSIR June 2019, the other physical chemistry questions. And yeah, if you are new to this channel, do subscribe. Okay, do subscribe this channel. I need more of your effort, like more of your support and love for this particular channel. Like this video if you like this, and comment whatever you want to ask, right? So that's all for this particular video, guys. Thank you so much for watching and have a great day. Bye bye.